All right, we're seeing this problem again in our opening problem in the book, so you can go ahead and just pause and read that. Okay, so consider those tomatoes in the opening problem. We could test the effectiveness of the fertilizer by letting the mean of last year's sample in a t-test. So there are two problems with this approach. In general, the sample mean will not be exactly equal to the population mean. The variation of last year's sample is ignored. So comparing one year to the next. If we're given the data for two samples, we use a two-sample t-test. Suppose we have two populations, and their means are represented, the mean of 1 and the mean of 2. Our null hypothesis would state that the means are equal. Or equivalently, that the difference between the means are 0. So that's your null hypothesis. The formula for the test statistic t and the distribution used to calculate the p-values are beyond the scope of this course. But we can use technology, which is a graphing calculator in our course, to find t and the p-value. So these are the same steps that we used on the previous lesson. And we're going to go ahead and do this example. So a pharmaceutical company has developed a new medication to help lower cholesterol levels. To test the effectiveness of the new medication, volunteers were separated into two groups. 15 patients were given the old medication, and 17 patients were given the new medication. The reduction in cholesterol levels after 4 weeks are measured for the two samples. So the first sample is the old medication of the 15 people. The average and the standard deviation are shown below. The new medication with the 17 patients, there's mean and standard deviation below. So we're going to conduct a two-sample t-test to determine whether the new medication is better than the old, and the significance level we're going to test at is 5%. So step 1, we're going to let the mean of the first sample be the population mean of the cholesterol reduction of the old medication. The mean sub 2 is the population mean of the new medication. The hypotheses that we should consider are the null hypothesis, that the two means are equal, or the alternative, that the old mean, the older medication, is less than the mean of the new medication. Therefore, the new medication is better than the old. Step 2, state that significance level, 5%. Then we would use our graphing calculator, and we would choose two-sample t-test. We would enter into our calculator the mean, the standard deviation, and the sample size for the original or the old medication. And then you would do the same thing for the new medication. The mean, standard deviation, and sample size. And then you would choose the middle. And here are the important numbers we want to look at. the t-test value, and the p-value. So there's the t-test value, and then the p-value. Step 5. Since the p-value is less than 5%, we have enough evidence to reject the null hypothesis in favor of the alternative. Since we accepted the alternative, we conclude that the new medication is better than the old. Pooled versus unpooled tests. You should have noticed that your calculator will give you the option of performing a pooled or unpooled test. In a pooled test, it is assumed that the variances of the two populations are the same. The samples are therefore combined or pooled to estimate this common variance when calculating the t and the p-value. In an unpooled test, the variances are assumed to be different. Therefore, use a different formula to calculate t and p values. In this course, we are expected to assume equivalent variances, and hence we will be using the pooled two-sample test. So that's what you need to know, is to use in our course, pooled two-sample test, which when we look at our calculator, we would default with the yes.